In this video, we're going to discuss inflection points and how they relate to concavity. So just to get us started, an inflection point is a point at which the function changes concavity. So it's going to either go from concave up to concave down, or concave down to concave up. So just graphically, so we can see what we're talking about, this is what is happening in this instance. Let's say we had some function that took on this shape. I would say roughly in this area here, we would have what's called an inflection point. And the reason that I'm saying that that is an inflection point is to the left of that point, we have a section of graph. In this area, we're concave down. However, in this area to the right of that point, the graph is concave up. We could switch this graph and still essentially get the same idea and still have an inflection point. Let's say if we had a function that looked like this, even though it looks almost reflected of what the other graph looks like, I would say roughly in this area, we change from concave up to concave down, and so therefore I would say this is an inflection point. An important thing to remember in how we're going to identify this is with the second derivative. That if the second derivative is positive, the function is concave up. And when the second derivative is negative, the function is concave down. Okay, so if we want to detect and find inflection points, there's a few things you want to be aware of. The first is that at the actual inflection point, the second derivative must be 0. And then what we're going to do is look to the left and to the right and see if that inflection point does indeed change signs. So to start with, to find the possibilities, we need to figure out where the second derivative equals 0. So to start, let's at least get the first derivative, f prime of x. The first derivative would be 4x cubed plus 3x squared minus 6x. And then we would lose the plus 2. The second derivative would be 12x squared plus 6x minus 6. And so we want to know where this thing equals 0, because that is our possible inflection points. So setting that equal to 0, I could probably solve this by factoring. The first thing I would say is to factor out a 6. So we'd have 6 times 2x squared plus x minus 1. We could divide that 6 over and we'd have 0 equals 2x squared plus x minus 1. Factoring this, I would say we want to somehow split this up. And since it's 2x squared, I know I'm going to split it up somehow into 2x and x. And I need to multiply and get negative 1 somehow. When I would FOIL this out, get positive 1. So I think we should put this as negative 1 plus 1. And you could check that. If you were to FOIL that, or I really should say distribute this thing back out, you would get 2x squared plus x minus 1. So solving that, 2x minus 1 equals 0, and x plus 1 equals 0. Here we get x equals positive 1/2. And here we get x equals negative 1. Those are our possible inflection points. So we need to test to the right and to the left of those points and see what happens. So first let's check x equals 1/2. A point to the left of that might be like at x equals 0, and a point to the right, x equals 1. And what we're looking to do is see if the concavity, if the second derivative changes signs. So if I plug in 0, f double prime of 0 would equal 12 times 0 squared plus 6 times 0 minus 6. F double prime of 0 is negative 6. So on the left side of 1/2, we're concave down. Checking to the right, F double prime of 1 would be 12 times 1 squared plus 6. 6 times 1 minus 6. And f double prime of 1 would equal 12 plus 6 is 18 minus 6. This is 12. So we did switch from negative 6 to 12. So from a negative to a positive. X equals 1/2 is an inflection point. Okay, so now let's try x equals negative 1. Well, picking a point to the left of x equals negative 1, let's try x equals negative 2. And so f double prime of negative 2 would equal 12 times negative 2 squared plus 6 times negative 2 minus 6. F double prime of negative 2 would equal 30. Picking a point to the right of negative 1, like let's say x equals 0, we've already computed that. F double prime of 0 equaled negative 6. So again, I've switched signs from positive to a negative. So x equals negative 1 is an inflection point.